Hi everyone, this is AutoML training community meeting on 29th of November. I think we can get started with the introduction. Do we have anyone else on the community call who just want to introduce himself to the community?
Yeah.
Go ahead, Carlos.
Carlos Costa here, just joining first time. So I'm Carlos Costa from IBM Research. I'm a principal research scientist here, driving the work around the building a platform for foundational models, right? So large-scale transformer-based models, end-to-end. And I work very closely with Red Hat colleagues, right? In fact, I have Jeremy here in the same room with me this time. You guys probably know Jeremy, and I have some of my other colleagues as well. So that's me.
Thank you, Carlos. Nice to meet you.
Yeah, I'm Andrew Scribner. I'm at Canonical. I don't think I've joined this working group meeting before, but I've been in some of the community and some of the other meetings. But I don't know, I like the work you guys do. Wouldn't mind just keeping a better tabs on it and maybe being able to contribute sometime in the future. So thought I'd join and see what's what. Nice to meet you.
Nice to see you, Andrew.
I'll jump in too real quick. I'm on the Red Hat end, so my team works very closely with Carlos. Just want to say hi. This is my first time being on one of these. I'm an engineering manager at Red Hat working on our OpenShift AI product. So I don't get to write much code anymore. I just manage people who do, but every once in a while.
Great. Nice to meet you, Alex.
My name is Jim Bush, and Carlos pulled Ted and I into Codeflare, so we've been helping Anisha and the Alex and the team with Codeflare and doing some Ray work.
Great. Nice to see you, James.
Jim basically introduced me, but yeah, I've also at Red Hat been working on Codeflare and Kubeflow for some time now.
Nice to see you, Anish. Yeah, anyone else, so we can get started?
Yeah, I'll go. I'm Sachin. I'm also new to this working group, been contributing to other groups. So Carlos' mini demo in the community call, so just wanted to find out more. So hi, everyone.
Great. Hi, Sachin. Nice to see you. Yeah, hey, David, go ahead.
Hi, everyone. My name is David Caruso. So outside, it looked like everyone from Red Hat joined today. I'm also. So I work at of that AI. We're a consultants company here in IT in Canada, and we work a lot with Kubeflow pipelines. And yeah, and we're eager to see the examples for the training operator.
Great. Thank you, David. Yeah, I think we can get started. So today we have a few items on the agenda. I think, first of all, we have a demo from Red Hat. We have a few folks from Red Hat that we can have a discussion around the Codeflare. And like, if you, in the meantime, if you want to add something more to the agenda, feel free to upload the doc. But I think we can get started with you, Carlos. So if you want to share your screen and just give a demo, feel free to do it.
Yeah, I'd be happy to. Yeah, thanks. Thanks everyone for making time for us, right? So I'll share my whole screen. Just give me 1 second. Because for those that missed some of the quick introduction, this one was likely not a good one to show. So yesterday I gave some kind of very high level overview of Project Codeflare that we've been doing for the past 2 years or so. So this was originated by IBM Research. And then quickly we got involvement from Red Hat, and this is something that now is truly joint, right? So I'll share like some of the challenge, because we're bringing this to this community because I think we're trying to solve a similar challenge and really looking for a way to grow this. Of course, looking to contributions and how it relates to some of the efforts around the train operator, the train SDK, right? So Codeflare really kind of originated from the pain point of running the whole workflow of foundation models. I mean, the way we call like the more general LLMs, so not only in language, right? So we train models beyond language, but the whole idea of training transform-based models, right? There's a lot of, as you guys know, data preprocessing, of course, training and fine-tuning. You guys are familiar with this, right? The challenge was really how you can abstract some of the complexities underneath. So we have kind of 2 buckets of users. One is more like the HPC type of folk, familiar with batch schedulers, right? And okay, dealing with a CLI. But then we had a lot of the machine learning practitioners that start from a Jupyter notebook. They don't want to know anything about Kubernetes itself, right? Not write a YAML file and things like that. And I'm sure this relates to you guys. So we spent some time building this Kubeflow SDK, which I'll demo in a little bit, just give you some context here. It's all about how to define resources and have some automation to deploy the backends to run these things. I'll take you through. But just so for like a mental map, we're building on top of a few things, right? So in this slide, you see some of the key things. So one is Ray framework. Ray is important for us for things like data pre-processing, some of the task orchestration and things like that. So we use Ray a lot of the times, not all the time. And then we have PyTorch. And we have been investing significantly also in this community, contributing, right? And basically integrating PyTorch better with MCAD. I'm sorry, with Kubernetes, and that happens for us through MCAD, which I'll mention a little bit. For PyTorch, we do both the training operator, but also something more recent called TorchX. I don't know if you guys are familiar. This is the universal job launcher for PyTorch. We also have that route in this stack, and I'll show this in action. At the bottom, just again for context, right? We develop our own Kubernetes native job scheduler for things like gang scheduling, topology aware scheduling, and so on, which is called MCAD. All of these open source projects you can see in GitHub. We did this by necessity, right? Because back like 3-4 years ago, there were no clear winner for job scheduling. So we needed things like separation between pod scheduling, job scheduling. So we come up with our own design. Now, of course, there are a few things in the community also looking to a way to put some of this technology. But right now, this is the whole stack that we have, and we want again to share some of this with this community here, so we can discuss overlaps, things that I believe, it can be complementary, right? With that in mind, I'll switch to the things in action, okay? And then we can have a discussion. I'm targeting Andrew, like 10 minutes or so. So you keep me on time here if I'm taking too much time, okay?
Yeah, sure. I think it should be good.
Very good. So what I have here, very simple, right? So I have an OpenShift cluster. So think of this as vanilla Kubernetes cluster, if you will. Of course, for us, it's all OpenShift. I have couple of things running here, right? Just like the operators. And what I want is to switch from this view, right? From like the operator view to the user. So all of that stack comes together into what we call Open Data Hub, which is the midstream for OpenShift AI, and Alex and others from Red Hat here can expand on that. Open Data Hub is something that runs on OpenShift AI. I'll skip like creating a project and things like that, but what you basically can get is this environment where, let me just move this window. It's basically a Jupyter environment, right? So I'll just get that Jupyter environment, which should look like this, right? And I'll show you a few things that we can do with this SDK and stack, okay? So there are two scenarios that I'll walk you through. Imagine that you, the machine learning practitioner that wants to do some fine tuning with Hugging Face Trainer API, okay? You know how to do this on your laptop, very familiar, and you want to do this on Kubernetes. There are two paths here. One is you okay doing this very interactively using the Ray API, okay? So you basically want to get exposed to the API. You need help to just basically get Ray backend stood up for you, right? That's one path. The other path is you have Python code, say PyTorch code. That's the API you know. You don't want to learn anything else. You want a way to basically go from that, something that you run on a laptop, to something that runs potentially like hundreds of GPUs, right? Those two users. So let's start with the very first one. So again, this is an example of fine-tuning BERT, okay? So here's the SDK that we have. So of course, we import this, show this in action. The next step, you have to log in to a cluster. So I'll just collapse this so you don't see like my credentials, right? But basically very simple token authentication. I'm connected to my cluster. Now comes like all the details of the SDK, right? So what we do is really give you this cluster object where the only thing that user does is to give resource details, right? I want like a backend, I'll give a name. I can pick like a namespace, right? And I can pick, of course, requirements, right? Number of CPUs, number of GPUs. We make this explicit, but also through the same API, we can also kind of guide you, right? You can also have like some t-shirt size. Say, I want to fine tune BERT, right? So we have an idea of like the level of resource that you need. So some of these things in the future can be auto-completed. Today we expose them, as you see. So here say I want 4 GPUs with this configuration. You can also choose a specific image if you want. And finally, you can choose whether or not you want this to be auto-scaled, in the sense that if I say instance scale true here, which is another feature that we have as part of the stack, I'll actually trigger more nodes to be added to my OpenShift clusters on demand, right? If I say false, I'll basically share a pool of resources that is fixed. This is important because under the covers here, we're actually submitting a batch job, right? That can compete for resources, and I'll show again this in action. Of course, you can also pick like machine types. In this case, I'll just pick a kind of V100 mid-end GPU instance because the high-end ones are hard to find. This is running on AWS, by the way. We have the same stack running also on a private, very large GPU cluster internally at IBM, right? So again, this one running on AWS. Once I define this cluster object, what it does, it basically creates a YAML file with all the definitions. I don't have to see this, of course, right, as a data scientist, which is ideal, of course. And once I have that object defined, I can now ask for like to have the backend stood up, right? So if I say cluster up, what happens here now, I trigger basically a batch job, right? So I'm putting a batch job in a queue, which basically it's a gang with all those resources. Because I'm using Ray with this path, I'm basically standing up a Ray cluster. Under the cover, I'm using Kubeflow, all the good stuff. All of this is abstracted from the user. I can check on the status of that cluster. It's actually, yeah, I waited too much. It's actually running already. It sometimes take, I mean, if you have more like competing users, you might get like in the queue. In this case, the cluster is ready. I can actually get the cluster details. And what I have here now, it's a cluster with those resources ready to go. And this is a Ray cluster, again, abstracted from the user. So can even like get the dashboard of Ray this way. I'll show you in a bit, it's coming up. So this is formed running on my Kubernetes cluster, right? All driven by that API. Underneath, again, I'm doing Kubeflow, job scheduling, all of that stuff. So if I go back to the data scientist view here, now that I have this Ray class, I can do different things. So in this path, I basically use the Ray API. I'll show you a path where you don't have to use the Ray API. But if I want to get exposed to Ray, then I can just grab the URL, I'm sorry, of this cluster this way, and then I can stand up a Ray session. All of this is pretty standard. Everybody familiar with the Ray API will be familiar with this. This is actually starting the session, which means for Ray, the beauty is that you just pass the dependencies here. So you basically get like images with all these dependencies pip installed for you. Sometimes take like 1 minute or two because actually pip installing this. And while it does the work, I'll just show what we can do once this is ready, right? So you have the Hugging Face Train API, right? So you guys are probably familiar with all of this stuff. I want basically to use Ray to parallelize this, right? To run like many instances of this. So this is very, very standard. I just need this kind of Ray annotation here. So I define a train function, annotate with the Ray remote. Within the function, I'll do things like tokenization, mapping, very, very, very standard things, as you guys know, things that I know how to run on my laptop. Some of the parameters for training, very standard. In fact, I took this from like a Excel, and then we go all the way to, of course, the model evaluation here, right? I'll just double check if the instance is still going. So it should be back soon, the array session. Once it is, the only thing I have to do is basically to run array get to basically instantiate that remote function. Again, this is for the array API, which many people are familiar. In this case, I'm using array to provide Hugging Face Trainer. Array session is up. I can see here now. So I'll basically run this function definition. I now say array get, and this will actually trigger the compute. So now this is running. You start very soon. With that backend, all driven from this Jupyter notebook, I'm doing some of the data partitioning first, right? And that's the beauty, because I can mix array data sets with the training code, right? One of the value propositions for array. And then I'll actually start some of the tokenization, I think is next. And then very soon, this will start training, okay? This is using 4 GPUs. If I say 16 GPUs is the same code, you don't have to change anything, right? I'll let this running for a while and switch to the next one, which is, what if I have like a vanilla Python code, right? I want to fine tune GPT. Here's an example, just out of GitHub, no changes, right? Using PyTorch DTP. I don't want to learn anything new. I just want to run this thing as is, right? So here's another Jupyter notebook showing an example with SDK again for a vanilla code, right? So here I just import the SDK again. I believe I'm already authenticated, but I'll do this again. Okay, I just have to update the token. Just give me 1 second. I should have authenticated this before. Just 1 sec. Okay. All right, so just so you guys see how I can authenticate this. Okay, now I'm authenticated to my cluster. Now what I do, same thing. I define a cluster object. I want to rush this a little bit. Stand up a cluster, right? See if the cluster is ready. It's going to take like a minute or so. And then while we wait, the difference here is that instead of exposing array, we have some of these job definitions. So we have a DDP job, FSDP job for PyTorch, right? Where you basically do exactly what you do locally. You define the arguments for PyTorch itself, use that job definition, you give a name, then give like the actual code that you want to run, list of arguments, right? The one that comes from here, sorry, and extra requirements. So if you need like a pip install or something like that. And here, I don't need anything underneath. I'm using Ray to manage the GPUs, but I don't expose the API. So I can just do, for example, now submit this job. And what it does, it basically gets that job and puts it in a queue. So I can actually check the status, right? So now it's pending. It will come up very soon. And you see that you're using TorchX as a way to get there. And from there, we can actually check before it starts again. I mean, it's going to take another minute or so. And once it's running, and it'll be like in a minute or so, I can just track this job, which is like running in batch underneath, right? I'll just show this running. Still pending, it's running a little bit. So what is happening here now? We have 2 sessions, right? 2 batch jobs running, 2 different APIs, all driven by this SDK. I'll stop here, see first of all it makes sense, and then I'd like to discuss with you guys how you think this relates to the training SDK. What are the pieces here that you think might complement? And just have a discussion. I'll stop here, so I don't want to use all the time.
Sure. Carlos, thanks for this. So I have a question regarding your initial setup. In your array cluster, you showed it has 1 worker and then you started a job. So can it do a distributed job here, distributed training?
Yeah, so the only reason why I did 1 worker is just to make sure that I would get the resources here. But the beauty here is for distribution, right? So we implemented this because we need like a very consistent way to get from like a 1 worker to 100 workers, right? So yeah, absolutely. If you say 100 workers here, and that's a typical scale that you run, you get this distributed across more than one node. Absolutely. And that's the main reason why we use this.
Right. So I have a question. So when you are doing the fine tuning, when you're running the fine tuning code and submitting to the to Ray using the Ray report abstraction, who is responsible for creating the distributed setup?
Very good question. So two paths, right? So one is, so Ray is doing the rank assignment, right? So if you want to go through Ray, basically Ray trainer talks to Ray to get rank assignment, the partitioning, right? That's the Ray path. But then you have to kind of tie yourself at some level to the Ray API. And some people are okay with that. The other path that I was showing, the second example, who is actually doing rank partitioning is actually underneath, is this torchx layer, which comes from PyTorch itself, right? So the API is PyTorch DDP, that you guys are probably familiar, right? Or FSDP, the new one. So the actual API is that one. You don't have to learn Ray or anything new, right? And then who is actually handling who gets what in terms of GPU and workers, that's torchx talking to Ray, right? So two scenarios.
Got it. So basically, your the distributed abstraction, if I understand correctly, that is implemented using your DDP specific module of the Cloudflare.
No. That's important, right? So we use vanilla DDP from PyTorch. All of this is actually how to get your environment set up for DDP to work.
Right,
okay?
right. Yeah, I get that. I can just relate to what we are doing, right? And then we can talk. I think that will provide a bigger context for you, like how the training operator works.
Yeah.
So, right, to give a context, right? So initially, we actually started in 2017 with a TF operator, which is specifically for TensorFlow. And what it does is creating the environment setup that you said, right? Like that's exactly what is being done in an operator. So a user can submit a TensorFlow job or PyTorch job, for example. Right? We added more operators, and right now that's a unified operator, which is called training operator. So when you submit different jobs or different types, like it can be TensorFlow, MPI, PyTorch, etc., the operator understands that and sets up the right distribution environment for you automatically. Yeah. So as you said, like similar to the DDP, we are following something similar in the training operator to provide a similar experience for the PyTorch, right? Where user says, I need X number of workers with this amount of CPU and memory, right? And after that, it starts X number of replicas, and it creates the distributed setup for you by setting the right environment variables. The only difference that I see is you're using Ray in the backend. We are directly running. It's a Kubernetes native application for us. So which means you are starting your job in a container with the environment setup. So it is basically running inside the container directly, right? Like on a Kubernetes abstraction, directly using the Kubernetes API to talk to each other. And rest all things are similar to how we have abstracted DDP. That's even taken, that is not even the realm of the user to actually say that I actually want X. Instead, they just provide a high level abstraction where they just provide that I want to submit a PyTorch job with X example. So in the initial time when we actually had, we just provided Kubernetes API SDK where they can actually populate the YAML using SDK, right? Like with various images, etc., image and other information, which was just populating the trainer API for Kubernetes. But later in the SDK, we added support where user doesn't need to actually do that. Instead, they can just provide a training function, which will automatically be run inside the container. So the current proposal for SDK, even like if you have noticed, the train LLM proposal is like one level higher than that, where similar to what you have done for fine-tuning Hugging Face, you could just say that I just need to run fine-tuning on a particular model with a data set, right? Like even the trainer function that you have written is also abstracted out in the SDK. So we have two sets of SDK. One is a lower level SDK, which is doing very similar to what you have done, where like you have to provide the Python function, and it will take care of it underneath. And the second one is even without even that, just providing for different providers specifically, like Hugging Face is one of that. That is one which is actually in the proposal.
Yeah, this all makes sense. One thing that I'll clarify when it comes to like a training, right? So, one option that we've been using as well is go straight to like Kubernetes via our job scheduler, but it could be other job scheduler, right? Because again, Ray there might not play a role, right? I mean, there are like advantages when you're doing Ray, but again, I mean, it's less valuable than for some of the other steps, right? One question though we have in mind is how you really unify, because if you're not, again, in our case, for example, there's a lot of like this data pre-processing steps that you have to take, right? Think of data cleaning, you want to remove, for example, hate and abuse speech, all these things, right? And Ray is super useful there. And I mean, you guys know that a lot of like folks in the industry are using. So if you're converged to like a one SDK, right? Do you see value of bringing that path, right, through Kubeflow and Ray as a way to unify? Now I have like one single entry point. Before I get fine tuning, I can do some of the like the data pre-processing using Ray. And the idea is to have it as high level as possible, right? Very much like what you do for PyTorch, right? Having the same for Ray. I think that's one angle that I think this can be complementary. When it comes to training, yeah, I love them. Yeah,
I completely agree with you there. So one story that we don't have yet in Kubeflow is the data pre-processing part, right? And you would have seen the discussion in the community meeting as well, looking from a data perspective, the processing part, right? Right now it is handled outside the Kubeflow. Your user doesn't have a component inside Kubeflow to handle that, right? Like people do it in other means and then use that, get it ready for the training operator to start kicking in. So that is one area which is not there, in Kubeflow yet. And just talking about how we have implemented. So from day one onwards, we have made it like purely Kubernetes native. Instead of, so that actually means we are using scheduling using Kubernetes, the standard API server itself, right? Not using the Kubernetes scheduler itself, not using Razor. But again, we have added support in the last release. We have added support for getting Ray clusters also up. We don't have examples there, so I'm not the expert there. But again, we could do something very similar to what you have done using Ray. But there is no other. Having said that, there is no way to connect to Ray with the easy way, right? Probably like this would be a good addition there, where when someone starts Ray clusters within Kubeflow, we could use these APIs to connect to it and then integrate with your API to start creating training jobs, for example.
Yeah, because ultimately, again, I mean, we want to write like a one single Kubeflow pipeline where we have like these things mixed. And I think there's some chatting in the chat. Exactly, right? And this is how we're driving these things even internally at IBM, right? So I think, of course, that makes sense. Question is, would make sense to start some design document around this idea, at least the Kubeflow Ray integration into, yeah.
Yes. So did you have a look at the current Kubeflow Ray implementation? So in the last community meeting, Julius was actually talking about that. Maybe I think we should just start from there to see where we are at from a Ray perspective. And after that, it is a vacuum, right? Like in Kubeflow, we don't have a way to, other than getting Ray clusters up, we don't have any other APIs to connect to that. So maybe I think that would be a very good start to see where we are at in Kubeflow. We could actually use something similar, which is already developed, and after that we could actually use some of your APIs, etc. For example, right? Integrate with that, where user can start using Ray clusters to get it started, right? That is a possibility.
Okay, that makes sense, and maybe like that's like an action on my side. I'll do the same for the training operator. Look more closely. I think you mentioned a few things. One thing that I wanted to ask as well is how much value you see like in patterns, right? So if you keep like abstracting these things, it's useful to understand like a typical configuration, right? So like come from use cases and things like that. How much you guys have for this already, and is this also something that you can contribute, right? a big chunk of what I'm describing is backed by 2 years of experience running some of these things, right, in the field. And we feel like there is an opportunity to bake in a lot of the automation patterns, right, and so on. Are you guys also interested in this angle?
Specifically from a Ray perspective?
Outside Ray, say, for example, you want to fine tune 7B parameter model,
Yeah,
right?
so I've been speaking like with so many companies, like how they use this in production, like how they use ray train or MPI. So many people say that for them it just was not scalable. Using ray train with like models in production was just not scalable. That is why they moved to MPI. And running MPI in ray just not possible, because like MPI requires specific configuration to be set up, right? So before we jump to discussion, may I ask you one question, Carlos, like about like so you said you've been using like the TorchX to trigger FSDP on Ray. So I have a question. So Ray basically a replacement for the PyTorch DDP, from my understanding, right?
The ray train. So let me clarify that. I mean, people get confused, and maybe that's something that I should say up front, right? There are two parts for Ray. One is the Ray API itself. There is like the Ray Train API. That's number one. Then there is Ray Cluster, right? Which is like a backend for resources. When you're doing when we're doing pre-processing, we use Ray API and Ray Cluster. When you're doing fine-tuning and training, we only use sometimes Ray Cluster. So we're not using the Ray API. There's no Ray Train in the mix. How we get there? So TorchX is this layer that basically allows DDP or FSDP to run in different backends, right? One backend is Kubernetes via Volcano. Another backend for Kubernetes is MCAD, straight MCAD, no Ray involved. Another backend is Ray. But Ray there is only used to grab resources, right? After you grab resources, basically doing MPIs, NICO communication, all that stuff, right? But for the very large scale training, we are not using Ray Train. We're not using even Ray Cluster. It's all straight TorchX to MCAD, right? So I want to clarify.
That makes sense. Yeah, because I think like we need to have integration between TorchX and training, because I mean, training operator directly interact with the Kubernetes API, as Jonah mentioned. And we don't have the cluster. So basically the problem with Ray, because it also has its own cluster autoscaler, which means like it has like the problem with the logical resources. It just not possible to vertically, you know, like have like vertical schedule, like the auto scaling, right? And like combining these things running on Kubernetes, as far as I can tell, like there are several problems which people is facing by running these kind of like the Ray clusters within Kubernetes, right? And I can see, you know, like I can see advantages of integrating TorchX with training operator SDK, for example, right? Because we can use this as a Kubernetes scaler, right, to run the training jobs. Yeah, go ahead.
Yeah, I'm sorry. Yeah, so exactly. And again, this is the way we're doing the large scale training piece. So what we did, and we can describe this in detail, is that to get to Kubernetes, we did TorchX, MCAD Kubernetes, right? There is a TorchX Volcano option, right? And I can contrast, like, I mean, between our implementation and Volcano, but that's how you get straight to Kubernetes start without Ray involvement for the large scale training, right? Our challenge, and I'm trying to articulate this, is the fact that we want that, right? Native training plus data pre-processing adaptation where Ray it's useful. So it's the same problem that you're discussing the other day, right? This heterogeneity, right? Where I need to run these things side by side.
Yeah, and the thing is like, sorry for interrupting. I think like the problem is with the industry. So you cannot run everything in Ray. So we have customers who are using like other version of Spark, or maybe have customers who are using like other version. Maybe they're using Dusk, maybe they're using Ray for data preparation, and maybe they have a microservice for training. Maybe they're using, I don't know, TorchX directly, or maybe training operator. So we just need to have a connection layer between these microservices, right? Because you cannot run everything in one microservice, right? Especially for the ML lifecycle.
And to add, like even in the current deployment, what I've seen internally and externally as well, the users of training operator gets the pre-processed data using some other frameworks, right? For example, Spark or Ray, as you said, right, with the Ray data, etc. So that is done outside, and then you start a distributed training using the training operator. So right now, like we found it difficult to actually unify that because there is no unified process to actually get to that. We haven't seen that yet.
Yeah, and what I mean unifying, just again, I mean to clarify, is it's not running everything array or runtime, but actually how we glue these things together from an SDK perspective, right? So I'm still running like two different backends when it makes sense, and of course we should be doing that. And then Trey, as you said, people are using even other things as well, and you should acknowledge that. But as a user, can I come to Kubeflow and write a Kubeflow pipeline where some of the automation to get these different backends is handled by me? I think that's where like the sweet spot really is, right? And that's what you're trying to bring to this community with some of the Ray enablement piece. Yeah,
it's an interesting discussion that way because since Kubeflow has Ray cluster support, I think there are many items which we can think to be complementary. For example, we can use some of your things here to actually have the data pre-processing part, right, and then connect to the training operator for the large scale training, right? Because that actually does a variety of cases, not just DDP, but again for multiple frameworks, and even inside PyTorch we have like much more features, etc. inside that. So maybe like complement the other parts which are not there, using like Ray would be one example for your pre-processing. I'm just thinking loud, right? And then connect to training operator with the data which we have already prepared, and then go for a large scale distributed training.
Yeah, I think we need integration within training operator SDK and the Codeflare. So you can directly trigger the underlying infrastructure, depends on the user requirements, right? So, like, because I don't know if actually, you can use, you definitely can run everything on Ray. This is possible because it's just like, a very low level of, of the abstraction to running the distributed Python workloads, right? You can run Spark on Ray with no problems, right? There is a project like Spark DP. But I think like, so Ray DP, I think it's called. I think like integration between like the training operator and the Codeflare makes sense to me as well, because then we can connect the maybe Ray for, as John mentioned, for pre-processing and then for training. Because I don't know if actually you can use Ray train for multi-GPU, multi-process training. Because imagine maybe like in Torch Run, you're familiar with Torch Run, right? You have like the thing is you have a multiple workers and you also have a multiple processes per worker, right? So maybe you have like 2 GPU for every worker. And I don't know if you can run this today with the train API.
I don't believe Ray train, but TorchX on Ray cluster, yes, right?
I see. So TorchX directly interact with the Ray cluster, as you mentioned, right? Okay, that makes sense.
But again, I mean, that's one route. You do that if you're already running other things on Ray, right? If it's the only thing you're doing, then the value of this is a little bit diminished, right? The other piece is how just kind of you handle dependencies. So one of the reasons why, I mean, some folks like Ray and Ray cluster a lot is because you don't have to maintain images. You can basically start with like a very basic one and do like a dependency injection on the fly with Ray, right? So if you have many users, for example, doing fine tuning while they're experimenting, they might import like different packages. This is useful, right? So again, I mean, Ray for data pre-processing, the whole thing. When it comes to training, if it's like a very large one, scale one, where you're not, change the image a lot, native, it's the way to go. We all agree. When you have some training, not super large scale, but you might need like a lot of dependencies, running TorchX on Ray, it might be useful. I think that's kind of the spectrum that you're seeing from that side.
Right. So in general, what the design wise, what we have taken from the very start is to actually provide a general framework where we always provide ability to plug into other frameworks. For example, like take it ML scheduler like Volcano, right? It's not fixed to a particular scheduler, right? We can support as many schedulers, or like even that's the same case with other pieces of the same stack as well, right? People, if they actually want to do any extra customization, they are free to do that separately. But again, from operator point of view, or from a Kubeflow perspective, we make it open, right, for others to integrate and keep a general interface for someone to plug it in. So we can actually follow something similar, right? For people who are actually having array clusters for the deep data preprocessing, we'll definitely provide integration in a training operator to get it to get that advantage directly from some of the work that you are doing.
Yeah. That makes sense. Okay, I don't want to monopolize the meeting, of course, right? Of course, I'm very excited about this. So thanks a lot for all the feedback.
It was really insightful. Thanks for that.
Yeah, no, thanks for making room for us. So what do you think are the next steps? You're really kind of eager to engage here and contribute in some meaningful way. What do you guys like to see from us at this point?
We need to start a design doc on issue to just drop our ideas, maybe just to brainstorm there are the ideas behind, like, integration training operator with Cloudflare, Ray within training operator, Ray within Kubeflow pipelines, and then just to see how we can connect these pieces together. Yeah, because the problem is, like, we just don't have this kind of like glue items, right? Even the Kubeflow pipelines, right, today, we don't have a really kind of good way for user to run Kubeflow pipelines within other Kubeflow components, because there are no, like, on the same kind of cluster, right, that are kind of separate microservices, right? Which means, like, if we provide this kind of glue layer, and I think I mentioned this previously with Spark, right, using maybe Arrow, like Apache Aeroflight, or any other technologies, like, intermediate cache layer, then this, the pipeline will come together much more cohesive, right, moving forward. So let's start the doc, and I think, Carlos, if you can drive this, it would be great, and so we can, like, participate, like, in the discussion there, and just to see what kind of integration we can do. And I believe even for using this kind of SDK within Cloudflare will be useful for people who use, like, this project. I mean, I'm talking about, like, integration with the training operator SDK and the Cloudflare, right?
I think so too, because again, even internally, we kind of do some of this already. So yeah, I think that makes sense as well.
Yeah, makes sense. Sorry for occupying it, but do you have any questions from the audience? I see some questions in the chat about GPU RNG MA support.
And I can take that very quickly, right? So keep in mind that when it comes to, like, collective communication, right? So we're not reinventing anything here. So we rely on NVIDIA NICO. So for topology within the node, this is all NVIDIA stack. For topology internode, right? So that's our job schedule, trying to pack thing as close as possible, right? So we schedule this like in a gang. Once we grab the resources, then it's all NICO based.
Yeah, we follow the exact same route. Yeah.
Okay.
Yeah, it makes sense. And I think, like, the major, again, difference is, like, the Kubeflow training operator doesn't try, like, we won't, like, recreate what TensorFlow community or PyTorch community provides for distributed strategy. We just provide the interface for you to run this on Kubernetes, right? So if tomorrow TensorFlow introduces a new, distributed technique, we just automatically will support it inside the training operator, because we don't need to change the core, basically. Does that make sense? Because we're only, like, responsible to spawn the resources on Kubernetes and specify the appropriate environment to run this on Kubernetes, right? So yeah, this, like, the advantages that Jonah mentioned in terms of, like, abstractions on top of this, like, well-known ML frameworks, right? Yeah. So I think we can, thank you so much, Carlos, for this demo. I think it was extremely helpful. And let's start the doc and just brainstorm the ideas there, how we can move forward.
Sounds great. So I'll get that started. I'll come back to you. I'll be joining these meetings now. Like so you guys have every other week, right? Yeah,
it's every 2 weeks. So one is, like, European friendly, and the one is US friendly. So because it's very, very late for you, John, as well. But yeah, try to manage, like, different time zones, but we'll see. So let's maybe, like, in the last 10 minutes, I just want to quickly mention, like, other items that we're going to quickly cover. I think before, Jonah, like, we jump to LLM, since David is here, we want to quickly speak about JAX, maybe just 1 minute. So David was actually reached out to me to think about how we can integrate JAX in FY24 in training operator. And I think all the pieces are there. So David, I would suggest you to take a look how we did for XGBoost, for PyTorch, for TensorFlow. And for JAX, I guess you just need to specify the different kind of environment variables, from my understanding, to run this in the distributed fashion, right?
Yeah, I mean, when you guys speak, like for me, the front end has always been using GCP and TPU. So for me, it's BMAP, PMAP, only this kind of three parallel primitives, and it just runs. So probably there is a lot of magic that happens beforehand. So if you can point me to that, I'll be yeah, that will be something cool that I will add to my New Year's list to add it.
Yeah, John, do we have any kind of, we have a developer guide, but it's it doesn't have all the information, but any other resources we can share?
Yeah, so it's not so I think it is a bit outdated. So happy to help David, like please feel free to ping me and then we can get it updated if you face any issues as such.
Yeah, just I learned JAX just to avoid to learn MPI. So I think I have a few examples that can run like that. If we can make it run, that'll be fun.
Sure.
Yeah, I think we need for JAX, we need a new kind of JAX job controller, like the JAX job custom resource, and the reconciler for, like we have like the unified reconciler, but basically like separate controller for the JAX. But we can maybe drop some ideas in the issue. Like just take a look in the developer guide, take a look at the code base. Like I'm familiar with Go, like at least like you know how to write these operators. Did you try to create any operators before? So just understand like what exactly we need to share with you, David.
So let me first get, because I haven't read the complete the develop part. I'm familiar with Go. I can define myself with that. But yeah.
All right.
So like a year before, yeah, you would have seen the discussion about JAX, right? And we didn't actually start during that time because of the support for distributed JAX. So are you aware right now, is it kind of like mature enough? So the last time when we checked, it was not mature enough, right? And then that was one reason that we thought of actually delaying the entire thing to get added to.
I can tell you that in the last year, people have moved from XMAP to these kind of things. I do believe that the parallel, especially because most of the example that I know that Google is working like on the open source side is to move to this kind of the PMAP API. I don't see change coming up, especially because XMAP was deprecated time and they want to focus on that. And I know that the 1.0 version is coming in the next few months.
Yeah, I think we need to use like the latest version. I mean, I see like they're kind of like switching between like what is the XMAP and PMAP, right?
Mm-hmm.
We need to see like more mature for us to implement, right?
No, I look. I know also someone that is writing a textbook that Google is supporting them, and he even told, hey, for the parallel part, we're just moving outside of XMAP and using just the PMAP primitive, so it will be fine with this.
Yeah, sure. So let's stay in touch, David. Let us know if you see any, like if you need any help, but then can guide you. And maybe we can even have like a session in one of the upcoming meetings to explain how operator actually works behind the scenes. Maybe just, I don't know, 20 minutes wrap up of the code base and just, go through the examples. So you can get familiar with this, and let me make a note for this. I think would be useful for everyone understanding how operator works. Yeah, thank you for the volunteer. I really appreciate it. I think JAX is like very popular. Like I can see a lot of like movements in this area compared to Torch, and for the optimization. So I think we definitely should think about it in the FY24. And I think like in the last like 5 minutes, I just want to cover like LLM. So John, I think we did some updates there, and we're almost ready with the final design. Do you want to share something from your side?
Yeah, so we are very close to merge. Probably like by this week we should have all the comments addressed, and we are looking to start implementing stuff from next week onwards. Debugger has already started creating issues, PRs regarding that, util PRs, etc. So I'll just give a very quick intro to that for Carlos specifically and others from Red Hat to see where we are, and that would really help, right? So as we discussed earlier, we already have an SDK API to create a distributed training or fine tuning, which you said, using Python functions directly without adding images. So that support is already there, and there are examples in the training operator regarding that. So what we are proposing in the newer one is a one level higher SDK API, where it is much more provider specific. For example, for someone who actually wants to start Hugging Face fine tuning specifically, they can they can just provide the model name, for example, and related information. So do fine tuning or training using the data set which is stored on S3 with different training parameters, right? So the idea is to provide multiple model providers and data providers, so that like like in the future we will add more and more support to other model providers and data providers. In the initial case, we will add support for the Hugging Face model provider and maybe like a couple of data set providers, right? Like S3, for example, S3, or maybe a local data set, or some other object store, for example. So this is a one higher level API. You can take a look at that, and please, and there's a issue which is created, which is tracking that. So idea is to, before training job, we will create necessary actions to download these models and data sets and keep it ready. And then we will have a pre-configured container which has enough and more logic to run a distributed training from the parameters that they have configured. So from a user perspective, particularly from a data scientist, there is nothing related to the infra here. It is all encapsulated, and like if you see the SDK, it is all specifically tuned for a data scientist friendly view, right? Like all the things which are required for a data scientist run. So that's the newer API which we have proposed, and we are very close to merge. So if you have questions, like feel free to ping me, and happy to answer that as well.
Yeah, I think I just wanted, I think, Jonah, like if Carlos and your team like is interested in this, I would just suggest review this. Maybe we can give like one more week for folks to take a look.
Yeah. So in the pull request, there's a train API proposal for LLMs. You can take a look at that.
Yeah, maybe just provide your ideas or suggestions or thoughts on this, and that will be really helpful before we actually do the initial design, right?
Sounds good.
Yeah. Thank you, Jonah. Yeah, I think like the one remaining things that we need to discuss about PVC and how we're going to download models. So we can do the just offline discussion around this, like whether we use empty dir or PVC initially.
So my thought is like this is a very big area, right? Like my general approach would be like, let's actually focus on a smaller or maybe like a contained task, and then get to a bigger one, right? Like it is not possible to actually get all the things together in the same issue that we are tracking. So we would divide kind of like a goal and known goals in this particular proposal, and separate it out for a future PR or a separate proposal.
Yeah, I think that was really helpful. So if you can update the proposal with this, because like, there is so much more we need to discuss. And
correct.
Yeah, I know that it's a case of also using init container for storage initializer, but maybe it's like not, it's maybe good for the inference, but maybe not the best for the distributed training, because imagine you have 100 workers, so you're going to have 100 init containers, right? Which is significantly slowed down, yeah.
Right. So the idea is slightly different, right? So in case of it's a single container, as you said, so one idea is we also have an idea of a chief or a master, right? So if there can be a specific master, or it can be like if it is just workers, like worker 0 can be a master. So in the operator itself, we have a notion who is the master, right? So we could actually run the init container only from the master process. And if the PVC is kind of like read many, then all the workers will see the data, right? So that I think that would be the ideal one. But again, it assumes that PVC is read many. You don't need to do that like in every container, right? So that's the idea that we have thought about, and what Deepankar is looking at.
Yeah. Then we need PVC. Yeah, you're right. Yeah, because like then we can even like share this through like the master class.
Exactly.
All right. Yeah, let's just define this. Yeah, because like we need to think about what will be like the user pod there, like because they need to like support this kind of like storage container then. But never mind. So let's continue discussion. Any other questions and last thoughts? All right, then. Thank you so much, everyone, for your time. Really appreciate the demo, Carlos, and your volunteer, David. And thank you, Jonah, for sharing LLMs. So let's just, like continue attending these meetings, and we try to find the best time for all of us, like to meet regularly. And I'm looking forward to our next step. So thanks so much for your time. Appreciate it.
Thanks, Carlos.
Yeah. See you soon. See you.
Collaborate.